In this presentation, we are going to look at climate change-related impacts that may be experienced in South Africa, observed climate trends, long-term adaptation scenarios and hydrological zones, direct and indirect impacts, regional climate change impacts, and climate change impacts on key sectors in South Africa. Over the last 5 decades, significant changes in climate have been observed in South Africa. Mean annual temperatures have increased by about 1.5 times the observed global average of 0.65 degrees Celsius, reported by the Fourth Assessment Report of the Intergovernmental Panel on Climate Change, or IPCC, for the period from 1950. Maximum and minimum temperatures have been increasing annually in most areas, with the exception of the central interior, where minimum temperatures have been increasing less strongly, and some decreases have also been observed. Hot and cold extremes have increased and decreased respectively in frequency in most seasons across the country, particularly in the western and northern interior. In almost all hydrological zones, there has been a tendency towards reduced rainfall for the autumn months, though annual rainfall has not changed significantly. Instead, there has been an overall reduction in the number of rainy days, implying a tendency towards an increase in the intensity of rainfall events and increased dry spell durations. Extreme rainfall events show a tendency towards increasing in frequency annually, and especially in spring and summer, with a reduction in extremes in autumn. Through the long-term adaptation scenario, a consensus set of climate scenarios for South Africa representing different future global emissions pathways have been developed. The long-term adaptation scenarios present climate trends and projections at national scale, and for the 6 hydrological zones of South Africa developed for the National Water Adaptation Strategy process. South Africa's climate future, up to 2050 and beyond, can be described using 4 fundamental national climate scenarios, which will present different degrees of changes in likelihood based on the impacts of global mitigation efforts and time. These are a warmer and wetter scenario, where temperature increases are below 3 degrees Celsius with greater frequency of extreme rainfall events. A hotter and wetter scenario, where temperature increases will be greater than 3 degrees Celsius with substantially greater frequency of extreme rainfall events. A warmer and drier scenario, where temperature increases are below 3 degrees Celsius with an increase in the frequency of drought events and somewhat greater frequency of extreme rainfall events. A hotter and drier scenario, where temperature increases will be greater than 3 degrees Celsius with a substantial increase in the frequency of drought events and greater frequency of extreme rainfall events. Effective global mitigation efforts will reduce the likelihood of scenarios 2 and 4, where temperature increases will be greater than 3 degrees Celsius, but increase the likelihood of scenarios 1 and 3, where temperature increases are below 3 degrees Celsius during this century. In both wetter and drier futures, a higher frequency of flooding and drought extremes could be expected, with the range of extremes significantly increased under unconstrained emissions scenarios. Whilst mitigation efforts are projected to minimize extreme changes, even under effective international mitigation responses, a change in climate under both wetter and drier climate futures is predicted to pose significant risk, having major implications on the socio-economic environment, which will be most felt by vulnerable groups and communities in South Africa. The long-term adaptation scenarios also presents climate trends and projections at national scale for the 6 hydrological zones of South Africa developed for the National Water Adaptation Strategy, reflecting boundaries defined by the water management areas in South Africa and grouped according to their climatic and hydrological characteristics. The grey represents the Limpopo, Olifants and Inkomati water management area. The pink, the Pongola Umzimkhulu water management area in KwaZulu-Natal in the east. Red, the Vaal water management area in the central interior. The dark green, the orange water management area in the northwest. Light green, the Mzimvubu Tsitsikamma water management area in the southeast, and blue, the Breed, Huritz, and Berg Olifants water management area in the southwest. These zones can be appropriately modeled and analyzed for direct impacts on the water sector and related indirect effects on other sectors. This table shows an example of rainfall projections for one of these hydrological zones, which is the Limpopo Olifants hydrological zone, under the 4 projected scenarios, which are higher spring and summer rains in a warmer wetter scenario, decreased spring, summer, and autumn rainfall in a warmer dry scenario, strong increase in spring and summer rainfall in a hotter wetter scenario, and strong decrease in summer, spring, and autumn rainfall in a hotter dry scenario. There are a wide range of potential impacts from climate change. These impacts, both positive and negative, can take place in different sectors. This slide shows examples of different potential climate change impacts on different sectors. In the next couple of slides, we're going to take a look at some of the potential climate change impacts in the different sectors. In agriculture, increased temperatures and variability in rainfall patterns with associated drought seasons are projected to impact on water availability, which is critical for the agriculture sector. These impacts are predicted to impact on crop production, particularly severe on the production of key cereal crops such as maize, wheat, sorghum, and barley in South Africa. Other crops of economic importance will also be impacted, such as beans, sugarcane, and grapes, as some major growing areas may become less suitable for growing. A changing climate may also result in increased potential for other areas which are previously not suitable for cultivation, presenting opportunities for exploration. Projected impacts may also result in changes in areas suitable for commercial forestry plantations, increasing from the traditional KwaZulu-Natal, Mpumalanga, and the Eastern Cape provinces to areas along the eastern seabound and adjacent areas. Warmer and wetter conditions are projected to alter the distribution of agricultural pests and diseases, which can result in huge losses for farmers. Temperature increases and reduced availability of water may result in increased health risks and impact on livestock, having severe impacts on intensive livestock practices. Increased temperatures, rising atmospheric carbon dioxide, and changing rainfall patterns are projected to place further pressure on our natural ecosystems, impacting on both fauna and flora species. Some of the identified impacts for biodiversity include loss of high-priority biomes like grassland and Indian Ocean coastal belt, increased impacts and loss of already threatened ecosystems due to changes in climate, degradation of natural habitats and loss of biodiversity due to significant land use change will impact on the ability of natural ecosystems to respond to climate change. Changes in rainfall patterns and temperatures are likely to have an impact on wetlands and ecosystem services they provide. Additionally, well-functioning ecosystems provide natural solutions that build community resilience. For example, buffering communities from extreme weather events, reducing erosion, increasing natural resources for diversifying local livelihoods, providing food and fiber, and providing habitats for animals and plants, which provide safety nets for communities during hard times. Climate change and its associated extreme weather events such as droughts, floods, and heat waves will pose numerous risks for the South African human health sector, further exacerbating existing challenges. Some of the impacts that will be felt here include increased temperatures, which may induce heat stress and increase the occurrence of respiratory, cardiovascular, and general disease and death. Increased temperatures, flooding, and drought could increase the incidence, incubation, and transmission of waterborne and associated communicable diseases, and more areas may become favorable for vectors such as malaria-carrying mosquitoes, which are predicted to spread within regions. Other impacts include food availability, which will decrease as a result of increased temperatures, leading to food shortages, and potential increases in food prices may lead to food insecurity, hunger, and malnutrition. Health impacts from natural disasters may result in increased injuries, deaths, and population displacements. Air pollution, primarily resulting from the burning of fossil fuels, may have serious health effects. Climate change impacts on human health are considered to have complex interactions within and across sectors. There are, however, numerous research gaps at this stage. Changes in rainfall trends and increase in the occurrence and severity of short-term flood events will have a negative impact on human settlements. This will include changes in weather, which will impact on industries as well as result in damage to key physical infrastructure such as buildings, pipelines, roads, electricity, and railway lines. This will result in the loss of productivity. People living in informal dwellings who are already vulnerable and will experience the most risk due to the temporary nature of their housing structures without extensive service or infrastructure. Weather-related damage to infrastructure often leads to the physical isolation of some communities who rely on the provided services of infrastructure. Damage to transport infrastructure will result in serious isolation and inaccessibility issues. Climate change will also influence the rural-urban migration rates, as those relying on farming at a subsistence level may no longer be able to due to changes in climate. Climate change will also have an impact on tourism, as some of the tourism assets and tourism supporting infrastructure may be affected by extreme climate-related weather events. Additionally, people living on the coast will also be vulnerable due to the impacts of sea level rise and coastal storms. Changes in precipitation and freshwater flow, sea level rise, increased temperature, and coastal storminess may lead to changes in physical processes and biological responses impacting on marine and benthic ecosystems. A change in climate is also likely to result in an increased frequency of extreme weather events, likely to impact on fishing activities due to declining catches, which could negatively impact on subsistence fishing communities and commercial industries. Furthermore, rising sea levels and increasing storm frequency will also have adverse effects on coastal communities, property, and infrastructure, including coastal roads and railways, fishing ports and harbors, and critical infrastructure due to rising sea levels and storm surges. Extreme events will also negatively impact on the coastal tourism industry. Sea level rise will also result in increased groundwater salinity in aquifers, threatening drinking water quality of dependent communities. It is predicted that the effects of climate change in South Africa will be felt mainly through its impacts on the water sector. Climate change impacts such as increasingly variable rainfall and higher temperatures will pose numerous risks to the South African water sector. Challenges will further exacerbate existing challenges. Example, droughts, floods, and decreasing water quality, and may create new ones. These impacts are likely to be felt across multiple sectors due to the cross-cutting nature of water and linkages with other sectors such as health, agriculture, biodiversity, and human settlements. Some of the main impacts in the sector include decreased quality of drinking water due to high evaporation rates. Periods of drought may result in decreased water quality due to increased effluent and salt concentrations. This will pose a risk to ecosystem health and human water uses. Increased rainfall intensities, flash floods, and regional flooding in some areas will result in litter and debris blocking water and sanitation systems, exacerbating existing challenges. Decreased water availability in some areas due to rainfall variability and increased periods of drought. Reduced oxygen concentrations due to contaminated natural water systems and high water temperatures may impact aquatic species. We have now gone through climate change impacts, as well as seen what risks and vulnerabilities these impacts will pose to key South African sectors. These projections were developed to assist planners, policy and decision makers in making decisions in their respective sectors. And while some of these projections might not display certainty or full confidence, it's important to bear in mind that preparation and consideration of changes and development places communities in a better position to deal with climate change impacts and also reduces risks and vulnerabilities.